All right, let's get started. So we have a pending paper. I guess I'm audible to everyone. Yeah, we have our pending paper from the past weeks. So let's quickly look at those sheets before we go to the new topic. So I guess we were discussing problem 8 in the previous class. So that's done. So let's quickly go to question number 9. Yes. So what is the value of n if 2 by 5 n minus 3 by 5 is equal to 9 by 5? Of course, you can take 3 by 5 to the other side. So it becomes 9 by 5 plus 3 over 5. That becomes 12 divided by 5. Okay. Now n is equal to the 2 by 5 on the LHS. When it goes to the other side, it becomes what? 5 divided by 2. So 5 and 5 goes away. And you can cancel 2 and 12. Your answer is 6. This is fine, right? Easy question. All right. Yeah. And but you could have done this way as well. To begin with, you could have cancelled the 5 everywhere to begin with. Like we have 2 by 5 n minus 3 by 5 is equal to 9 by 5. You can cancel off this 5 everywhere. Right? So that way it is much easier. This is 2n minus 3 is equal to 9. So we have 2n is equal to 12. N is equal to 6. So you don't have to deal with fractions. Okay. How did I cancel off that 5? You're basically multiplying both sides of the equation with 5. Okay. You're multiplying the entire equation with 5. All right. So this becomes 5 into 2 by 5 n minus 5 into 3 by 5 is equal to 9 by 5 into 5. So here 5 and 5 goes away, 5 and 5 goes away, 5 and 5 go. So that is 2n minus 3 is equal to 9 again. Okay. So this is cool, right? I hope you worked this out before. Shall I go to the next question? Yeah. So next question is using the equation 17 plus 27 is equal to minus 7 omega. So this is the symbol omega. This is the Greek letter omega. The value of the expression 10 times 1 minus 21 omega is. All right. Again, we have 17 plus 27, that is 44, is equal to minus 7 omega. So your omega becomes 44 divided by minus 7. That will be minus 44 divided by 7. Yes. Now 10 times 1 minus 21 omega is going to be 10 times 1 minus 21 into minus 44 divided by 7. Yes. So this is 10 times. You have two negatives. Negation of negation is positive. So that is 1 plus 21 into 44 divided by 7. And here 7 and 24 you can cancel off. We have 3. So that is 10 into 1 plus 3 into 44. 3 times 44 is 44 into 3 is going to be 132. So this is 10 times 1 plus 132. This is 10 into 133, which is 1330. Fine? Is this fine? Yeah. An alternate approach is, see, when you look at the question, see, you have minus 7 omega here and you have minus 21 omega here. Do you realize that minus 21 omega is nothing but 3 times minus 7 omega? Do you realize that? Do you realize that minus 21 omega is nothing but 3 times minus 7 omega? Yes. So minus 7 omega is given as 44. Why don't we just go and plug in that number here? And you have the answer directly, right? So it becomes 10 times 1 plus minus 21 omega is 3 times 44. So if you do this way, it is much easier. What did I do? Instead of actually finding omega value, I noticed that this minus 21 omega that is appearing in the required expression is nothing but a multiple of minus 7 omega that is given on the RHS of the original equation. Yes, this is easier, right? If we can make that observation. Yes, yes, no. Is it confusing? Is this confusing? No. Okay, cool. All right. So let's go to the next sheet. Yes. So this is problem sheet number 4. So what is the first question? First question, we have 10 times 23 plus 7. So in the LHS, 23 plus 7 is 30. And 100y plus 100y is 200y. All right. You can just add the like terms. These are like terms. Okay. You can do the normal algebraic operations on the like terms. So we have 10 into 30 is 300 and we have 200y. So your y is nothing but 300 divided by 200, and that's nothing but 3 by 2 or 1.5. 1.5 or 3 by 2 is our answer. Yes. Give me a yes. Yes. Okay, next question. Question number 2. The solution of the equation 5m minus 2 times m minus 1 is equal to 8. 5m minus 2 times m minus 1 is equal to 8. Again, look at this. There is a bracket here. There's a parenthesis. And we can simplify that first. Minus 2m. Minus 2 times minus 1 is plus 2 is equal to 8. So here you have like terms. You can combine those. 5m minus 2m is going to be 3m plus 2 is equal to 8. So we have 3m is equal to 8 minus 2, which is 6. So your m is equal to 2. Fine. See, such questions do come in SAT, okay? But the key is you have to solve it in maybe 10 or 20 seconds. So that's the only thing you need to be careful about. You can't take all the time. You can't go and pick up your calculator and plug in the values and try to get the answer. We don't have that kind of a time. So just be very quick with your pen and paper and very quick with your mental math. Now, question number 3. What is the solution of the equation -3 into 2u minus 1 is equal to -21? All right. So one way is you can simplify the LHS. We have -3 into 2u, which is -6u. -3 into -1 is +3 and -21. So we have, you take -6u to the other side to get a positive number, and -21 to the other side, we have 3 plus 21. So we have 24 is equal to 6u, and we have u is equal to 24 divided by 6, which is nothing but 4. Okay, this is okay, right? Or you could have got rid of this -3 in the beginning itself, because take -3 to the other side. This is basically multiplication, right? So this is -3 into 2u minus 1 is equal to -21. So -3 is being multiplied with some quantity. When it goes to the other side, it becomes division. So you have 2u minus 1 is equal to -21 divided by -3. Negative disappear. We have 21 by 3, which is 7. So you have 2u minus 1 is equal to 7. 2u is equal to 8. And you have u is equal to 4. You can do this way as well. Cool. Okay. So if you're stuck somewhere, do let me know. All right. If you're stuck somewhere, let me know. I hope these are easy problems. So let's go to the 4th one. So question number 4 has 7 by 9 alpha, 7 by 9 alpha minus 4 by 9 alpha is equal to 1 by 4, 1 by 4 plus 5 by 12, 5 by 12. Yes. So how do you simplify? On the LHS, we have 7 by 9 minus 4 by 9 alpha. On the RHS, I have to simplify this expression. So the common denominator is going to be 12. So this, if you want to make it 12, that should be 4 times 3. And the numerator we have 1 times 3 plus 5 by 12. So that is going to be 3 divided by 12 plus 5 divided by 12, which will be 8 divided by 12. which will be 2 divided by 3. And in the LHS, we have 7 minus 4 divided by 9 times alpha, which is 3 divided by 9 times alpha. And on the RHS, we have 2 by 3. So your alpha is going to be 2 by 3 times 9 by 3. And here 3 gets cancelled with 9. So you're left with 2. Cool. So are you comfortable with solving equations which involve fractions now? Comfortable with fractions? Tell me. Yes, you can quickly do it without trying to go and pick up a calculator. You can do it quickly, right? Yes. Okay, cool. So let's go to the next question, which is question number 5. The solution of n in the equation 10.40n plus 1.60n plus 94 is equal to 754. Again, we have 10.40n. It's question number 5. Plus 1.60n plus 94 is equal to 754. So in this question, instead of fractions, we have decimal numbers. Okay. Again, I hope you're thorough with the decimal operations. In the LHS, you can combine these like terms. So this is going to be 10.40 plus 1.60 times n. You can always take this 94 to the other side. We have 754 minus 94. And this 10.40 plus 1.60 will be, this becomes 0, 0. We have 1 to this side. So we have 12. So at 12n is equal to 754 minus 94. Sorry. 754 minus 94. So this is going to be 0 here. This is 6 and this is 6. This is 660. Okay. Now we have 12n is equal to 660. So your n value is nothing but 660 divided by 12. And do you observe that you can quickly cancel off 6 on both numerator and denominator to begin with? So if you cancel with 6, this is going to be 1, 1, 0. Here it will be 2. 660 is basically 6 into 110. Right. Again, you're left with 110 divided by 2, which is quickly 55. So the answer is 55. Yes. Shall we go to the next question? So in question number 6, what do we have? We have 3 into 5z minus 8 plus 2 times 4z minus 1 is equal to 24. So this is our question. So this is a regular question. You just begin by expanding this bracket here. So we have 15z minus 24 plus 8z minus 2 is equal to 24. You just combine the like terms. The like terms being 15z and 8z. So that is going to be 23z. I'm sorry, I made a mistake when writing down the question. No, it's correct only, right? It's correct. Yeah. So we have, so we can take the numbers to the other side. So that is going to be 48. Oh, okay. I guess there is a mistake in the question. Okay. Otherwise, we won't get a nice number. Let me correct it for you. See, rectify this question here. See, you rewrite it as 4z plus 1. Make it 4z plus 1. Rectify the question here. Make it 4z plus 1. Please do correct the question. Make it 4z plus 1. So in that case, it will be 4z plus 1. We have plus 2 here. So minus 24 goes to the other side, it becomes plus 24. Plus 2 goes to the other side, it becomes minus 2. And you have a 24 there. So it's 48 minus 2, which is 46. So yeah, z is going to be 46 divided by 23. So answer comes out as a nice number. Make a correction in the original question. There's a typing mistake in the question. Rectify that. Okay, this is fine, right? Simple question. Okay. Yes. Now let's go to the next question. Question number 7. Question number 7. So here you have decimal numbers, 0.6 times 5z minus 8 plus 0.4 times 4z minus 1 is equal to 4.8. Okay, now one way to approach this question is, see, please listen carefully. One way to approach this question is you just directly do the regular operation. So you have to expand this bracket first. You have 0.6 into 5z minus 0.6 into 8 plus 0.4 into 4z minus 0.4. Okay, this is one term. This is the second term. Is equal to 4.8. Clear? In the first step, I applied the distribution property. Now, this expression is 0.6 times 5. What is 0.6 times 5? You think of 6 times 5. 6 times 5 is 30. So 0.6 times 5 is going to be 3. So this is 3z. This is 6 into 8 is 48. 6 times 8 is 48. So this is 4.8. Okay. Now, here again, 0.4 into 4 is 16. 4 into 4 is 16. So it's 1.6 z minus 0.4 is equal to 4.8. Okay. So far, so good. Oh, in this question again, there is a typing mistake. I'm sorry about that. Say again, in this question, there is a typing mistake. You just correct this number as plus. Again, correct this number as 4z plus 1. Correct this number as 4z plus 1. Okay. Please make that correction now. Please make that correction now. Make that correction now. Now we have 3z minus 4.8 plus 1.6z plus 0.4 is equal to 4.8. So what do? You combine the like terms. We have 3z, we have 1.6z, that is 4.6z. And you bring the other terms to the other side. So we have 4.8. And this goes to the other side, it becomes plus 4.8. This goes to the other side, it becomes minus 0.4. Yes. So this becomes 9.6 minus 0.4, which is 9.2. So 4.6 times z becomes 9.2. Your z is 9.2 divided by 4.6, which is 2. Why is it 2? Because it's nothing but 92 divided by 46. 92 divided by 46 is 2. So that is cool. Got it? Got it? Got it? Yes. See, do you realize that in this problem sheet, all these 5 questions are essentially the same? Did you realize that? Of course, there's a typing mistake again here. It has to be plus 1. But now, do you realize that all these 5 questions are essentially the same? See, I've created the 5 questions in such a way that they are the exactly same questions. Do you realize that now? Okay, I'll tell you how. See, we are done with the first question. Okay, in the first question, there is no confusion because there are no fractions involved. There are no decimal points involved. Okay. Now, in the second question, you have decimal numbers appearing in the question. So, what was the approach we took? We just did the decimal arithmetic. Okay, the normal way where you do follow the properties of arithmetic properties of the decimal numbers, but you ended up getting the same number. But see, you can quickly see that. See, this was our question. Listen carefully, please. This was our question. We have 0.6 times 5z minus 8 plus 0.4 times 4z plus 1 is equal to 4.8. And remember, our previous question was, this is our question number 6. Please listen carefully. This was our question number 7. And our question number 6 was nothing but 3 times 5z minus 8 plus 2 times 4z plus 1 is equal to 24. Now, why did I tell that these two questions are same? It's simple. See, listen carefully. This 0.6, I'm going to write it as 6 by 10. Okay. And the 0.4 is going to be 4 divided by 10. And this 48 is 48 divided by 10. Okay. Now you get rid of 10 everywhere. You can do that, right? You can do that, right? Get rid of 10 everywhere. From the entire expression, you just get rid of 10. That's cool. You're aware of that, right? Is that fine? Is it confusing? Is it confusing? No. Okay. Now, from the entire expression, you just get rid of, you just cancel out a 2. When you cancel out a 2 from entire expression, this becomes 3, this becomes 2, this becomes 24. So that becomes 3 times 5z minus 8 plus 2 times 4z plus 1 is equal to 24. Now you are left with the same question as in question 6. See, there are no decimal numbers now. There are no decimal numbers now. You don't have to deal with decimals now. You don't have to deal with decimal points now, right? So that's what. So the another way to do question number 7 is to convert it into a question without decimal points. Convert it into a question without decimal points. So that will end up as question number 6. Question number 7. In question number 7, if you get rid of the decimals, it will end up like question number 6. Okay? Understood? Do you want me to explain again? Do you want me to explain again? Please do let me know. Okay, what about others? And by the way, if you're messaging me personally, please do message me on the other ID. There is one more account of mine which says participant ID 305575, right? So that is the account I'm taking the chat on. So is this easier? I mean, you get rid of decimals and bring in nice numbers. Is this easier for you? Or the original method? Is this easier for you? I mean, you just need to know every trick. That's all. You just need to know every method. Okay, it is not necessary that you should apply this in the exam, but you should know all this method. Why? Because during an exam you tend to panic. Okay, and you don't know which method to apply. You will apply the method that will come to your mind the first. Okay, the first method that comes to your mind, you just go ahead with that. You don't have to keep searching for different methods, but you should be aware of all the techniques, all the ways by which you can crack a question. That's absolutely necessary, right? But with a lot of practice, even during an exam, you will be in a position to understand which method to use during an exam. Okay, the optimal way of cracking a question in the least possible way, in the least possible time. All right, so it's important that you know all the methods of simplifying an expression, solving a question. Remember, we are still on solving linear equations in one variable, and this is the easiest part of the syllabus. I mean, from the algebra part, this is the easiest portion in the syllabus. Okay, and soon we'll see more complicated equations. We'll soon see functions. We'll see equations involving two variables. Okay, but if you're thorough with the one variable equations, see, that's why I'm spending so much time on this. We'll be dealing with all type of question that we'll encounter during an exam, all type of mathematical operations with which you'll work on questions. You will have decimal operations, you will have fraction operations. You have to use all you do this, right? I don't know, here in India it's called board mass. I think in US it's PEMDAS, right? The order in which you evaluate an expression. Okay, so that's also applicable when you have variables. Okay, see, variables are just like numbers, just that it's an unknown number. Okay, so you don't have to worry about the number to begin with. You just do normal operations on those variables, just like you do operations on your regular numbers, and you end up evaluating the number in the end. That's all. The simple logic. Okay, to begin with, you don't know the actual value of the symbol. You just deal with the symbol as if it was a number, and then at the end you realize that the number has a value. That's all. So all these basic operations you should be very thorough with, and using pen and paper as well as doing mental math. Not just I mean, you can't always depend on calculator, okay? Because calculator is going to be a time wasting exercise most of the times. Do you do all problems using calculator in your school? Everything is done using calculator? Okay, anyway, I'll tell you when to pick up a calculator also, okay? Because sometimes you will really have to pick up the calculator. We'll come to a situation. Yes, again, let's go to question number 8. Question number 8. There was a small correction in the question. Instead of minus, make it plus. Again, do you realize that it's nothing but it's same as question number 6 and 7? Do you realize that it's same as question number 6 and 7? Okay, I'll tell you how to solve this question if such a question appears in the exam. So we have 3 by 5 times 5z minus 8 plus 2 by 5 times 4z plus 1 is equal to 24 by 5. Okay. Now the regular method is you see the denominator and you are extremely happy to see the same denominator everywhere. Why? You can simply get rid of it. You can just cancel off this 5 everywhere. Happy. Right? Now do you realize that you are left with the same question in problem number 6? Same question in problem number 6. Do you realize that it's the same question in problem number 6 once you cancel off this 5? Yes? Yes. Okay. Now you can go ahead, right? From this step, you can go ahead and do the normal process. As in, this is 15z minus 24 plus 8z plus 2 is equal to 24. So we have 23z and 24 goes to the other side. It becomes plus 24. 2 goes to the other side. It's become minus 2. So it is 46. So your z is 46 divided by 23, which is going to be 2. Yes. So again, you see, I have framed the same question in terms of fractions, in terms of decimals, everything. Okay. Again, let's go to the question number 9. Let's go to question number 9. Okay, question number 9 may look slightly difficult, but again, you'll soon realize that it's nothing but question number 6 again. Problem number 9 is nothing but problem number 6 again. Let's see how. Okay, listen carefully. In question number 9, what do we have? We have 3 times z minus 8 by 5 plus 2 times 4z by 5 plus 1 by 5 is equal to 24 divided by 5. Okay, what is the normal approach? You try to expand this. So we have 3z minus 24 divided by 5 plus. Here what do? You expand again. We have 8z by 5 plus 2 by 5 is equal to 24 by 5. Now you try to combine the like terms. So we have 3z plus 8z divided by 5. And you take the numbers to the other side. 24 divided by 5 plus 24 divided by 5 minus 2 divided by 5. So it is going to be 46 divided by 5. And here, LHS, how do you evaluate this? You take z out. It is going to be 3 plus 8 by 5. And this is going to be z into 3 into 5 divided by 5 plus 8 by 5. So this is going to be z into 15 plus 8 is 23 by 5. Okay, on the RHS we have 46 divided by 5. RHS is 46 divided by 5. And LHS after simplification becomes this. Now what do? Just cancel off 5 and 23 and 46. you're left with 2. So your Z is 2. Yes, this is fine, right? So this is how you normally do a problem which involves fraction. Okay. But in this question, you have to observe that almost everywhere you have the same number in the denominator. So in this question, in this specific question, if you see a similar question, you have to observe that you have the same number in denominator everywhere, almost everywhere. So in this case, it's much easier to get rid of the denominator. So how will I get rid of the denominator? How will I get rid of the denominator? So we have 3 times z minus 8 by 5 plus 2 times 4z by 5 plus 1 by 5 is equal to 24 divided by 5, right? So you observe that you have 5 everywhere in the denominator. How will you get rid of 5? You just multiply with 5 everywhere. Multiply the entire expression with 5. Multiply the entire expression with 5. Got it? How will you get rid of the 5 in the denominator? You just bring in a 5 in the numerator. So you just multiply with a 5 everywhere. So in the first term, you can distribute this 5. So this becomes 5z minus 5 into 8 by 5. In the second step, the second term, you distribute this 5 everywhere. And the RHS 5 and 5 directly gets cancelled. It becomes 24. It becomes 24. Now, do you realize that these 5 and 5 goes away? This goes away. So what are you left with? You have 3 times 5z minus 8 plus 2 times 4z plus 1 is equal to 24. Now there are no decimal points. Now there are no fractions. Just a simple equation. Just a simple equation. No decimal points, no fractions, just a simple equation. And this is nothing but your question number 6 again. It's your question number 6 again. So this is cool, right? I'm just telling you how the multiple ways by which you can approach a problem, because during an exam you don't know which method will strike you, because of most of the time the first instinct that will come to your mind when you see a new question is most of the times it's panic. The first instinct that comes to your mind during an exam is usually panic. So during an exam you may not always end up getting an optimal method. So it is important that you should know all the methods. That's first point. Secondly, with sufficient practice, if you do a lot of questions, if you practice a lot of questions during an exam, that will definitely help you. Okay, you'll be quickly able to come up with the shortest method. Okay, so our idea is to solve a lot of questions, crack a lot of questions, practice a lot of problems. Do you know that in India, the SAT counterpart is called the JEE? Have you heard of this exam called JEE? Just like you have Ivy Leagues in the United States, we have something called IITs. Have you heard of IITs? Yeah. So we do have an exam called JEE. And the syllabus for this exam is nothing but physics, chemistry, and mathematics. And a typical Indian kid will solve at least 5,000 questions in every subject. A typical Indian kid will solve at least 5,000 questions in physics, chemistry, and mathematics when he's practicing for the exam. I'm just telling you. It's a fun fact. At least 5,000, okay? You don't have to do 5,000 questions and all, but the idea is you should get a lot of practice. You should go through that kind of drilling. There's no other way. That is how test prep works. I mean, these standardized tests are designed in such a way. Like, see, you have a limited time. And you have to crack so many questions in that time. So it's like, say, you have 80 minutes. Okay. 80 minutes, you should be able to do 58 questions. So your entire preparation program is designed in such a way that, okay, in this 80 minutes, you should be able to crack as many questions as possible. So ultimately, only those 80 minutes matter. Okay. So you should be able to crack as many questions in that 80 minutes of time. So you should be extremely quick. Unlike a regular school exam, you have so many questions to crack in that 80 minutes. Anyway, let's get back to this. So again, you're done with question number 9. Now you have question number 10. Again, there are decimal numbers appearing in the question. Let's see how to crack this. So you just expand the bracket here. We have 3z minus 3 into 1.6 plus 2 into 0.8z plus 2 into 0.2 is equal to 4.8. So this is 3z minus 4.8 plus 2 into 0.8 is 1.6z plus 2 into 0.2 is 0.4 is equal to 4.8. Now you combine the like terms. If you have 3z here, you have 1.6z here. So that is going to be 4.6z. And you'll take the regular numbers, your numbers to the other side. So we have 4.8 plus 4.8 minus 0.4. Right? So you have 4.6z is equal to this 4.8 plus 4.8 is 9.6. Why? Because 48 plus 48 is 96. 4.8 plus 4.8 is 9.6. Minus 0.4 is going to be 9.2. Cool. So your z is again 9.2 divided by 4.6, which is 2 again. Again, it's the same question. Okay. Is this fine? Is this fine? Tell me if it's confusing. Do let me know. Hello, 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 hello. Okay. It's cool, right? Yeah. And do you realize that all these problems are same? 6, 7, 8, 9, 10. So if you need some kind of revision, if you need some recap, You just go through all these 5 problems once again, because the same question is framed in 5 different forms. So some of them involve fractions, some of them involve decimals, some of them involve integers. Okay, so if you can crack these 5 questions very quickly, you understood all the operations of fractions, you understood all the operations of decimal numbers. You also know how to solve a linear equation which involve brackets and like terms. So in this problem sheet, we are discussing about questions that involve like terms, parentheses, and which needed simplification. And we are about to run out of time, so we'll just quickly see 1 or 2 problems from the next sheet. We have 2 more sheets pending. So in this sheet, we are discussing about questions which have variables on both sides. Okay. So when you have variables on both sides, the idea is to collect variables on one side and the numbers on the other side, right? You do understand this, right? When you have variables on both sides, the idea is to collect variables to one side and the numbers to the other side. Okay. And when you're collecting variables to one side, it may be used as a thumb rule to try and make the coefficient of the variable as positive. Because if you collect variable on one side, it'll be positive. On the same thing, if you collect it on the other side, it'll be negative, right? Right. So it is better, it'll be much easier when you try to collect the variable on one side, try to, as far as possible, try to make it as a positive coefficient. Right? So the first question, 15x minus 3 is equal to 9x plus 1. So the idea is collect variables to one side. So we have 15x, the 9x goes to the other side, it becomes minus 9x. 3 goes to the other side, it becomes 3 plus 1. So 15x minus 9x is 6x. 6x is equal to 4. Your x is 4 divided by 6, which is 2 divided by 3. 2 divided by 3. Okay. Next question. The solution of the equation 0.5 plus 0.3m is equal to 0.7m minus 0.3. Instead of integers, you have decimals. Now we are very comfortable doing decimal operations, decimal arithmetic. So here you should be careful, as in there's nothing wrong in collecting variable on LHS or collecting variable on RHS. But our thumb rule is, as far as possible, try to collect the variable on the side which will make the coefficient of the variable as a positive number. Okay. So do you realize that if you take 0.3m to the other side, it makes much more it becomes much easier, right? So you take 0.3m to the other side. So we have 0.7m minus 0.3m is equal to 0.5 plus 0.3, right? Can I take 2 more minutes? Just 2 more minutes and then we'll wind up. Yeah. Now this 0.7m minus 0.3m is, if you take m out, it's 0.7 minus 0.3. And 0.7 minus 0.3 is 0.4. So this is 0.4 times m. And the LHS we have 0.8. So yeah, m is 0.8 divided by 0.4, which is 2. Okay. See, we have 0.5 m plus 0.3. No, sorry. We have 0.5 plus 0.3 m is equal to 0.7 m minus 0.3. See, what did I do? I just took this to the other side, this to the other side. We have 0.3 plus 0.5 is equal to 0.7 m minus 0.3 m. You just simplify this, becomes 0.4 times m. Here it becomes 0.8, and your m becomes 0.8 divided by 0.4, which becomes 2. Cool, right? So in this question, in this method, we have taken 0.3 m to the RHS. Okay, you could have taken 0.7 m to the LHS as well. Nothing would have been wrong. Okay, you would have got the same answer. How? This is fine, right? This is fine. Is there a confusion? Do you need further explanations? It's fine. Okay, cool. Yeah. On the other hand, if you had taken 0.7 m to the other side, I'll write the question once again. 0.5 plus 0.3 m is equal to 0.7 m minus 0.3. Now, if you had taken 0.7 m to the other side and 0.5 to the other side, what would have happened? It will be 0.3 m minus 0.7 m is equal to minus 0.3 minus 0.5. Right. And this will be 0.3 minus 0.7 times m. And here it will be minus of 0.3 plus 0.5, which is minus 0.8. And here what happens? What is 3 minus 7? 3 minus 7 is minus 4. 3 minus 7 is minus 4. So 0.3 minus 0.7 is 0.3 minus 0.7 is 0.4, right? Because 3 minus 7 is 4. So 0.4 with a negative sign, m is equal to minus 0.8. And you're happy because, you just have to take them minus 0.4 to the other side. So minus 0.8 divided by minus 0.4. So again, the negative term, negative gets cancelled. You're left with 0.8 with 0.8 divided by 0.4, which is again 2. So what do you think, which approach is easier? Obviously the first one, right? Right? The first approach is easier, right? So it's easier if you try and collect the variables on to one side, which would make the coefficient of the variable as a positive number. But however, if you don't do that also, you will end up getting the same answer. It's absolutely fine. Okay, there's nothing wrong with this approach. Okay, see, ultimately what you need to know that you should be very thorough with the arithmetic operations. Okay, you're still doing arithmetics here: addition, multiplication, division, subtraction. And even if it involves negative numbers, you should be very comfortable. Even if it involves fractions, you should be very comfortable. Even if it involves decimal points, you should be very comfortable, because these are like the foundations. If you're strong with the foundations, It's cakewalk. It's a cakewalk. It's pretty simple questions. And do let me know if you're struggling with some of the foundation, some of the arithmetics. I may be able to help you out. Maybe in a if you guys want a recap on the arithmetic operations, if you want a recap on decimal operations, if you want a recap on fraction operations, do let me know. Maybe we can have a small class on that. But do let me know. Okay. For the time being, I'm assuming that everything is fine. Okay. If you have any difficulties, do let me know. All right. So we'll complete the rest of the sheet in the next class. And again, for this week, we don't have a new topic. We'll go to the next. Hopefully, we'll go to the next topic in the next class. Okay, then. See you.